Guys, this is Carrie, and this is going to be the answer key video for homework 12. One thing I think I realized is I think this problem has a typo in it. So I think we need to change this number to 72. I'm sorry for not catching that in advance. Let's see if this works. So to determine if the type of music played while taking a quiz has a relationship to results, 16 students were randomly assigned to either room playing soft classical music or room playing soft rap music. So we have our two experimental groups. The results on the quiz were as follows. Okay, great. So some of the classical scores, some of the rap scores. John correctly rounded the difference in the means of his experimental groups as 7. How did John obtain this value, and what does it represent in the given context? Justify your answer. So if he found the difference in the means to be 7, then he probably found the means. So we need to find x bar for this one and x bar for this one. Now to average these, you add up all of these values, and then you divide by the number of values you added up. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So you can't see what I'm writing on my calculator, but I'll do in parentheses 74 plus 83 plus 77 plus 77 plus 84 plus 82 plus 90 plus 89, all close parentheses, divided by 8. That gives us a mean of 82 for the first one. And we'll do the same thing for the second one. So 77 plus 80 plus 78 plus 74 plus 69 plus 72 plus 78 plus, please make sure you use the edited value here, 72, all divided by 8, gives us 75. And so we have the two means here, and if we do the difference in the means, 82 minus 75, that gives us the 7 that John found. So how did John obtain this value, and what does it represent in the given context? Well, it looks like on average, students in the classical room did 7 points better. Okay, so what we talked about in class today is sort of the superficial understanding of this is if you could have picked between the rooms, you may have picked the classical room, just based on seeing that they did 7 points better. Like, that is a lot better. But kind of all the examples today, especially the one that was very plain and not very statistical, illustrated that there are other factors that can cause the difference to be 7. Like, maybe this group just had like a couple of really sharp students, and whichever group got those groups, whether it was rap or classical, would have looked better. So to test out whether the classical music room actually had a statistically significant difference from the rap room, we can run some simulations of resorting the groups. So what that will do is we'll take all their scores and we'll scramble them between random groups. But we don't have to worry about the details of that because that's happening behind the scenes on the computer here. So to determine if there's any significance in this value, John re-randomized the 16 scores into 2 groups of 8, calculated the difference in the means, and simulated this process 250 times as shown below. Does the simulation support the theory that there may be a significant difference in quiz scores? Explain. All right, so this is one where they unfortunately do not give us the mean and standard deviation. So we actually have to use the data from the graph. So it looks like we observed a difference of 7. Plotting 7 on our graph would be 0, 1, 2, 3, 4, 5, 6, 7. So we sort of have this impression of a bell curve here. We'll usually have like a middle 95%. And what we're curious about is, should this 7 be included or not included in that middle 95%? And since we don't have the values, we can't use this approximation of a bell curve that I just drew. Instead, what we have to think about is, well, we received a difference of 7 in our experimental case. In the random groups, that came up 3 times, and 1 time came up more extreme. So if we think about potentially this being out of the middle 95%, then it looks like there are 4 values that were at least as extreme as the 7 that we observed. For random samples, I should say. at least as extreme as the difference we saw in the experiment. But it was 4 out of 250. So it'd be better to think about this as a percent. So it looks like 4 out of 250, using my calculator, is equivalent to 0.016, which would be 1.6%. So we only see a difference in the random groups as extreme as 7 points apart. 7 points difference in the mean. Uh, 1.6% of the time. So because this only happens 1.6% of the time in the random groups, it must be that classical music had an effect. And what that means is it was statistically significant. It was a significant difference because it does not occur in the middle 95% of the random groupings. So I hope that this made sense. I know these problems have kind of a contorted logic to them, but please give it another listen if it wasn't clear, and ask me any questions that you have about them if you want to work on these more. All right, so now on to the more traditional regions prep problems. The graph of the function of p of x is shown below. So which of these could be the equation for p of x? Well, p of x has roots at -3, 2, and 3. So we know that p of x must have factors of the form x minus 3, x minus 2. Ooh, sorry, I want to highlight where I got this from. When 3 is a root, that means that x minus 3 must have been a factor. When 2 is a root, that means that x minus 2 must have been a factor. And when -3 is a root, it must mean that x plus 3 is a factor. So our factors must have been x plus 3, x minus 3, and x minus 2. And I guess I've put these together in a way that sort of gives away the answer. It looks like it's choice 1 because this could have been factored forward by using difference of squares to give us this result. Determine the equation of the graph shown below. All right, well, this is y equals, it's definitely a cosine function because it starts at its maximum. Its amplitude is 0.5, so it should be 0.5 there. Its period is pi, so what that means is we'll have a purple b value, which we'll have to calculate later. And then are we adding a value to our sine graph or cosine graph here? No, because the midline is still where it originally is at 0. So we do not need to add a value. So to calculate that b value, what we do is we say when we plug in pi, b times pi, for x, we should be completing a full cycle, which is 2 pi. So solving for b, we find that b is 2. So we get final equation here, y equals 0.5 cosine of 2x, because b is 2. A parabola has its focus at 1, 2, and its directrix at y equals -2. 1, 2. This is the focus. Y equals -2 is the directrix. And the vertex for a parabola is halfway in between these. So these are 4 units apart. The vertex will be halfway in between, which is 2 units below and 2 units above. Well, 2 units below the focus, 2 units above the directrix. Our parabola will open upwards because it has to surround the focus. So we get y is equal to Now a normal parabola would have equation x squared, and that would mean the vertex is at the origin. But because we have to move 1 unit to the right, it should be x minus 1 in side transformation, because it will move us the opposite of what you expect. Now it's actually on the x-axis, so you don't have to move up or down at all, so it's like we're adding nothing, which is equivalent to not adding anything. And then the formula for the a value here is a is equal to 1 over 2 times the total distance. That total distance was 4 between the focus and directrix, so it will be 1 over 8. And that will be your final answer. All right, guys, I hope you found this helpful. Again, please rewatch problem number 1. Record any questions that you still have. Sorry about the typo here. I hope that you changed it. See you in class on Tuesday, Monday, depending on which class, sometime in the future.